Hi, and welcome to the Magic of Mathematics with Mrs. Arnold Harsley. Today we're going to be looking at Basic Algebra Part 2, which is adding and subtracting terms. We will look at what are like terms, how do you add and subtract like algebraic terms, what are the rules, and what does collecting like terms actually mean. So what does it mean to collect like terms? You may find in your classroom at school, your teacher might say, okay, today we're going to collect like terms. It might refer to collect like terms in your maths textbook. Either way, when you collect like terms, it means you are adding or subtracting terms that are like, as in they are the same type. And we'll look at that a bit more as we go. So here are the rules. Rule number 1, you add or subtract the coefficients for like terms and then you collect the like term. So in my previous video in Algebra Basics number 1, we looked at terms, coefficients and pronumerals, variables, etc. But just as a quick refresher, if you've got 6a, then a will be the pronumeral or variable. And 6, the number that sits behind it, because there's an invisible multiplication sign in there, is the coefficient. So if we look at this example first, 7a add 5a, a is the like term, the coefficients are 7 plus 5, so 7 plus 5 is 12, and then you collect the like term of a. You could say that you went to the shop and bought 7 apples and then you decided to buy another 5 apples. How many apples in your bag now? There are 12 apples. Using that, we've now got this example here where the pronumeral or variable is b. So you could say that they're bananas. You could say we've got 10 bananas, and then you're going to subtract 4 bananas. Maybe you ate them. And that would leave you with 6 bananas. So again, you're subtracting the coefficients of 10 with 4, and then you're collecting the like term of b. This example here, let's say C is cherries. You went to the shop, you bought 16 cherries, then you decided to buy another 4. On the way home, you bumped into a friend and she gave you another 2. You can see they're all cherries. There's the C. So you add the coefficients. 16 plus 4 is 20, plus 2 is 22, and then you collect the like term of C. So rule number 2, remember when you add and subtract, the terms you collect must be like. So let's have a look at that. In this first example here, if we say A are apples and B are bananas, you've got 10 apples, went to the shop, you bought another 2 apples, and then you bought 10 bananas. So we can collect the A's because they are like terms. So if you've got 10 apples and 2 apples, that will give you 12 apples. But you can't add the bananas to the apples. You can't have banapples. So you would have 12 apples plus the 10 bananas. It needs to be kept separate. They're not, A and the B are not like terms. So if you went to the shop and bought 10 apples and then another 2 apples, and then you bought 10 bananas, in your shopping bag would be 12 apples and 10 bananas. So let's look at this example. You've got 20 bananas, subtract 6 bananas and add 4 cherries. So again, the bananas are like terms, the cherries are not. So you can collect the like terms for the bananas. 20 subtract 6 is 14. You've got 14 bananas and then you just add the 4 cherries on. You can't simplify or make that any smaller. And then this example here, you've got 7D, add 3C, add 3D. So let's say that they're dogs and cats. You've got 7 dogs, add 3 cats, add 3 dogs. Cats and dogs are not the same, so you can collect the dogs together, but the cats have to stay separate. So you've got 7 dogs plus 3 dogs, which equals 10 dogs, and then you've got the 3 cats. So that's 10D, add 3C. So rule number 3, if a pronumeral is on its own, it means there is a coefficient of 1, an invisible coefficient of 1. I've seen many students forget that. So if you've got an A on its own, it's the same as 1A. If you've got an X on its own, it's the same as 1X. It doesn't matter which letter of the alphabet from A to Z you're using as the pronumeral or the variable. If it's on its own, it means there is an invisible 1 as the coefficient. So in this example here, if you've got 5A add A, it is the same thing as saying 5A add 1A. You went to the shops and bought 5 apples, and then you bought 1 apple to give you a total of 6 apples. In this example here, you've got 12C subtract C. So behind this C is an invisible 1. So you're actually saying 12C subtract 1C. You went to the shops and you bought 12 cherries, and then you ate 1 cherry. So you're left with 11 cherries. So rule number 4, the same pronumerals can be written in any order and they will be classed as like terms. So example 4AC here is the same as 4CA. So AC is the same as CA. It just means there's an A in both and there's a C in both. It's like amazing cherries are the same as cherries that are amazing. There is a reason for that, and that is because there is an invisible multiplication sign in between those pronumerals. So that's actually A multiplied by C and C multiplied by A. If you put numbers in there instead, you've got 5 times 2. I've just selected that as an example. It's the same as 2 times 5. It doesn't matter which way round you multiply it, the answer is always going to be 10 for that particular example. There's a special word for it. It's called commutative. And what that means is you can multiply it in any order and the answer will still be correct. We'll look at multiplying algebraic terms in more detail in my next YouTube clip, part 3 of basic algebra. All right, so if we look at the examples on here, we've got 3AB add 4BA. So in AB and BA, there is a standard A in both and a B in both. So yes, they are like terms. So we collect the coefficients. 3 add 4 is 7, and we add the like terms. So now you have to decide, do you write AB or do you write BA? It actually doesn't matter. Either way will be correct, but I always like to write mine in the answer in alphabetical order. In this example here, you've got 6DE subtract 2ED. So let's look at the term. It's DE and ED. There's a D in both and there's an E in both. So they are like terms. DE is the same as ED. So now we subtract the coefficients. 6 subtract 2 is 4. And then I'm going to write the DE in alphabetical order. In this example here, you've got x squared and a y, and then you've got a y and x squared. So you've got an x squared in both and a y in both. So they are like terms. They're just written in a different order. So now we can add the coefficients. 3 add 2 is 5, and then I'm going to write the terms in alphabetical order to give you 5x squared y. And in the final example, again, you've got an x squared on both sides and you've got a y on both sides. So again, they're like terms. 10 subtract 5 is 5. Then you add the x squared and the y. So let's just go through these and see which of these are like terms. Could we add or subtract these terms together? So if we look at the first example here, you've got an x and an x. They are like terms. So yes. In this example, you've got an A and a B. That's like trying to add or subtract apples with bananas. No, they're not like terms. In this example, you've got an X and a Y. That's like trying to add an X-ray with a yacht. It can't be done. They are not like terms. In this example here, and this is an example where a lot of students that I've seen over the years become confused. If you've got x squared and x, a lot of students think they are like terms. They are not. X squared is the same as x squared. X is the same as x. But x squared is not the same as x, and x is not the same as x squared. So that one is a no. In this example here, you've got x squared and an x squared, so they are like terms. In this example, you have ABC and BAC. Both have an A, both have a B, and both have a C. So they are like terms. In this example, you've got an x squared on both sides and a y. So they are like terms. In this one here, you've got 6GH and 9HG. Again, the same letters. They've just been transposed, written the other way around. They are like terms because there's a G in both and an H in both. And then in this example, you've got a y squared and a y, and an x squared. X is not the same as x squared, and y is not the same as y squared. So those two are not like terms. Okay, we're going to try a couple of more challenging examples. It looks a bit daunting, but as long as you follow the rules, you'll be fine. So I'm just going to pick a different colour for each one and let you know one final rule that I didn't cover in the other slides. So first of all, I'm going to start here. Get my pen working. So I've got 4A, 4 apples. So I'm going to look along the line here to see where there are any more like terms, and I've just got here another 12 apples. But here is the other rule that's really important when you're collecting like terms, and that is to take the sign with the like term so that you know when you've got a whole line of them like this, whether you're going to add them together or whether you're going to subtract them, and even at times whether it will go into a negative. So now there's no more apples in that line, no more pronumerals with the letter A. So we're just going to add 4A with 12A, which will give us 16A. It's going to use a different colour. Now we've got positive 7B, subtract B, because we know B and B are like terms. I'm just looking down here, no more B's. Now remember, if B is on its own, it's the same as 1B. So if we have 7B and you subtract 1B, it's like having 7 bananas and you eat one. How many have you got left? You have got positive 6B. Remember to ensure you put that sign in. Okay, so moving along, you've got positive 6x squared. So have we got any other like terms for x squared along here? We've got y, x squared. Remember to take the subtract with it, and there's no more there. So we're looking at 6x squared, subtract 2x squared. Well, 6 subtract 2 is 4, so it's plus 4x squared. Now we need a different colour again. We've got positive 10y, add 8y. Have we got any more y's? We do. Here, subtract 2y. Remember to take the sign with it. Take the sign. Really important. So you've got 10 yachts. You're going to add another 8 yachts to your collection. So you've got 18 yachts. Then you decide to sell 2. So you've got 18 yachts, you sell 2, and that gives you 16 yachts, remembering to put the addition sign in. And now we've got positive 5BA and positive 12AB. So remember there's an A there and a B there. So they are like terms. So you've got 5, add 12, which is 17. And remember, I always write them in alphabetical order, A, B. And then that just leaves you, pick a different colour, with negative C or minus C. So when you collect like terms with this one here, you end up with 16a, add 6b, add 4x squared, add 16y, add 17ab, subtract c. Can't get it any smaller than that because there are no more like terms to add or subtract. So now let's look at this one. I'll keep the purple pen on. I like that one. You've got 10 ABC. Is there any more like terms along here? Yes. Subtract 2 BAC. I know that they're like terms because there's an A in both, there's a B in both, and there's a C in both. So you've got 10 of them. You're going to subtract 2, so that leaves you with 8. And again, I write mine in alphabetical order. Looking at the next one along, you've got positive C squared and D. Here, you've got D squared and C. So remember, C is not the same as C squared, and D squared is not the same as D. So there are no more like terms there. So you would write that one down next. Coming along to the next one, you've got add 9y squared x. So looking along here, I can see we've got positive 3xy squared. So there's a y squared in both. There's a y squared there, and there's an x there. So I know they're like terms. So you've got 9 here, and you're going to add another 3 to give you 12xy squared. You've got plus 7y there. There's no other like term, so you just write that one down there, and going to the grey, this one on the end. So when you add all of or subtract those together, you end up with 8abc, add 6c squared d, add 12xy squared, add 7y, subtract 2 even d squared c. It sounds more daunting than it is, but if you remember to colour code it like I've done and collect them one part at a time, and remember to take the sign with it so that you know whether you're adding or subtracting those signs, then you will be able to complete all your work quite easily. So today we looked at like terms. We looked at what is meant by a like term, what the rules of collecting like terms are, and we looked at examples of adding and subtracting and collecting those like terms. We also established that adding and subtracting like terms is the same as collecting like terms, and that collecting like terms is another name for it. So thank you for watching today. If you found this clip useful, my channel is The Magic of Mathematics. Leave some feedback about what you liked or what can be improved. But until next time, see ya.